We have learned to graph linear functions by making input and output tables, graphing those ordered pairs, and then connecting them to make our line. We're going to look at a second way that we can graph a linear function using the x and y intercepts. The y-intercept is the point where a line crosses the y-axis, and the x-intercept is the point where a line crosses the x-axis. So very simply, if you look at the line that has been graphed below, right here, you'll notice that that line crosses the y-axis. That point is called the y-intercept. If you were going to write the ordered pair to describe that y-intercept, you go over 0 on the graph, and then we come up 1, 2, 3, 4, 5 to the y-intercept. So we would describe the y-intercept as being 0, 5. That's the very specific point where the line crosses the y-axis. If we were going to describe the x-intercept, the point where the line crosses the x-axis, again, we would describe that with an ordered pair. We go over 1, 2, 3, 4, 5, 6 on the x-axis and up 0 on the y. So the ordered pair that describes the x-axis, or excuse me, the x-intercept is 6, 0. That's the very specific point where the line crosses the x-axis. Now, I want you to notice, when we listed the y-intercept, what is the value of the x-coordinate? It's 0. When we listed our x-intercept, what was the value of the y-coordinate? It was 0 as well. When we try to find our x and y intercepts, we're going to use that number of 0. Notice that both the x and the y intercepts, when we listed the ordered pairs, both of them contained 0 for at least one of the coordinates. That's a significant part of finding our x and y intercepts. Now, let's look at the steps. If I want to find my x-intercept, I'm going to plug 0 in for y. I'm going to solve the equation for x. And then I'm going to substitute the answer that I got into an ordered pair, something 0. Very similarly, if I want to find the y-intercept, I'm going to plug in 0 for x. I'm going to solve the equation for y. And then I'm going to substitute whatever I got for y into an ordered pair that's 0, and then that answer. Let's look at that in action. Okay, so if we want to begin by finding the x-intercept, here are our steps that we're going to use to find the x-intercept. We're going to plug in 0 for y. So let's take our equation, and where we see y, let's fill in 0. 0 equals 2x minus 6. Step 2 says we're supposed to solve for x. So let's solve this equation. Let's add 6 to both sides so that the equation is 6 equals 2x. Let's divide by 2 on each side so that we get 3 equals x. So my x-intercept is 3. Now it says to substitute that value into this ordered pair. So I would write my x-intercept as 3, 0. Now, let's find the y-intercept. The steps for finding the y-intercept are here. It says plug 0 in for x. So let's do that. Y equals 2, instead of x, we'll fill in 0, minus 6. Now let's solve. Y equals 2 times 0 is 0. Y equals 0 minus 6. 0 minus 6 is negative 6. So our y-intercept is negative 6. We're supposed to substitute that into the ordered pair. So we'll have 0, negative 6. Now that we have our x-intercept and our y-intercept, we can graph this line simply by plotting the two intercepts and connecting them. So using our graph, let's go ahead and do that. Our x-intercept is at 3, 0, and our y-intercept is at 0, negative 6. Once we've graphed those two ordered pairs, we're simply going to connect them. And that's our linear function. We've graphed a line without making an input-output table. We've graphed it simply by finding the x-intercept, where the line is supposed to touch the x-axis. We found the y-intercept, where the line is supposed to touch the y-axis. We've plotted those 2 points, and then we've made our line. Let's look at another example. Let's begin here by finding our x-intercept. Here's our steps again. Let's plug in 0 for y. So 5x plus 3 times 0 equals 15. Now let's solve that equation. 5x plus 3 times 0 is 0. So 5x plus 0 equals 15. We don't need that plus 0, right? So that's just 5x equals 15. Let's divide by 5 on both sides. And we get an answer that says x equals 3. So my x-intercept can be written as 3, 0. Let's go ahead and graph that at 3, 0. Now let's find our y-intercept. Again, here's our steps. Let's plug in 0 for x. So 5 times 0. Our final example is negative 2x plus y equals negative 10. Let's find the x and the y-intercepts to graph this line. Let's begin with our x-intercept. We're going to plug in 0 for y. Negative 2x plus 0 equals negative 10. We don't need the plus 0, so we'll write that as negative 2x equals negative 10. We'll divide by negative 2 on both sides, and we get x is equal to 5. So we have our x-intercept. Let's plug in the x answer for the x-coordinate 5, 0, and we graph that point at 5, 0. Now let's find our y-intercept by plugging in 0 for x. Negative 2 times 0 plus y equals negative 10. Negative 2 times 0 is 0. So we have 0 plus y equals negative 10. We don't need to keep the 0. That leaves us with y equals negative 10. And when we plug that into an ordered pair, we have that as 0, negative 10. We graph 0, negative 10. We connect our 2 points, and we have our line.